Well, welcome everyone to the Thursday, October 20th, 2022 session in our series on new business in Asia driven by climate tech and sustainability. So for our speakers today, it's already October 21st. Our speakers are both joining us from Singapore this morning, where it's 8:30 in the morning, I think. So I'm very happy to welcome everybody. I'm Richard Dasher. I direct the US-Asia Technology Management Center at Stanford. We want to say thank you to all of our member companies whose names were on the list that were on the slides we were showing, because it's their financial support that allow us to put this series together. And it's been very interesting. This is our fourth session in our series on climate tech and sustainability-driven companies in Asia. We talked about upcycling trash last week, and 2 weeks ago, we talked about food tech, euglena, used for alternative jet fuel as well as food and food supplements. So today we're moving into the energy sector big time. And also combining that with circular economy. So that we're going to talk, first of all, with Mr. Mike Lim, who is a partner of the venture capital firm TRIREC, which is Singapore-based and is doing investments specifically in these kind of sustainable impact areas. So Mike has more than 15 years of experience in business planning and execution and in advising in areas such as mergers and acquisitions and fundraising and corporate financing. Before joining TRIREC, he was he had senior management roles in an investment bank and in various operating corporations in Asia. He's also the co-founder of several companies in the IoT space and in the future foods space. And in addition to his partner work at TRIREC, he is also a member of Innovate 360, which is a Singapore-based agri-food technology incubator. Joining Mike is one of the portfolio companies of TRIREC, which is Green Lion. Love the name of the company. And we're very happy to welcome Mr. Leon Farrant, who is the CEO of Green Lion. And Leon has CEO experience in several firms as well as executive management experience. Before Green Lion, he was with a global energy industry company and led large dispersed teams and also large technical projects. So he has a wonderful statement at the end of his bio about focusing on consensus building and also supporting diverse communities. So we're delighted that both of our speakers can be with us today. What we're going to do is really more of a fireside chat format. I do want each speaker to be able to introduce their organization to us, and then we'll just kind of take it from there and keep everything conversational. For those of you who are joining us on Zoom, please put your questions during this recorded part of the program into the chat window, and I'll read them out loud. This will help things keep up a good pace. And we'll also have the ability for people here in the auditorium to ask questions. Please wait for us to get a microphone to you if you have a question. So, Mike, thanks very much for shortening your first cup of coffee to be with us this morning. If you'd tell us a little more about TRIREC, that would be great.
Thanks for having me for the session. Pleasure to be here. Thanks, Richard, for the introduction, and thanks everyone for taking time to join the session itself. Maybe I just dive straight into TRIREC, what do we do, and etc. Just wondering whether I can share my screen. Yeah, so a quick introduction about TRIREC. Just going to scroll right down. So we are a VC firm. We are based in Singapore, and we are actually a pretty specialized VC firm in the sense that we invest specifically into the decarbonization space. When I talk about decarbonization, I'm actually talking about greenhouse gas and three things about greenhouse gas: sequestration of greenhouse gas, prevention and reduction of greenhouse gas. So as long as the startups or the company that we're looking at can do, one of these three, we're happy to take a look at them. We are a global fund, even though we sit in Singapore, so we invest globally. In fact, half of our portfolio right now sits largely in North America, and then the rest are mainly in Asia and in Israel itself. And how we look at the decarbonization space, decarbonization is actually it's one word, but it's a very big word, right? Because it basically cuts through, different facets of our life. So how we frame our investments is that we basically look into the 5 key pillars that has been proven to be emitting the most greenhouse gas. That would be the energy sector, the food and agri sector, the mobility and transportation sector, the building sectors, and the manufacturing sectors. So what we do is that we actually split into those 5 sectors itself, and then we dive into each of these verticals. We look through the whole value chain, and we try to identify areas of which we think would be the most appropriate opportunity for us to invest as a VC, generating VC kinds of returns. And for us, we are a early stage investor. When I say early stage, we generally mean pre-Series A to Series B. So that's the sweet spot that we normally would invest in for our very first check, and then we do our follow-on investment from there. There are cases whereby we do look at even earlier stage company in the seed stage, etc., but that's normally not the norm. Our ticket size range from 2 to 5 million for the very first track that we put in, and then we do follow on, and that probably would bring us up to 10, 15 million per portfolio company. I did mention that we are global. Currently, we are actually in our second fund at this current junction. A little bit of history. We started in 2015 when our founders, Melvin and Lawrence, founded TRIREC. I think at that point of time in 2014, 2015, I think the word decarbonization has not really popped up right, into everyone's mind at that point of time. There are some mention about sustainability probably at the point of time, but to be honest, in Asia, that wasn't something very big then. Most of the fund that was looking into this investment in Asia at that point of time is a lot more focused on the fintech space, on the e-commerce space, etc. So we are one of the very few that actually focus on in this area in very early stage of the sustainability story. We raised a very small pot of money, close to $8 million US, and then we deployed it across 8 portfolio companies. We fully deployed the first pot of money in 2018, and then we started raising for the second fund in 2019 itself, and started deploying in 2019 itself. So it has been a 8 years journey. Has been a very interesting journey. We've seen a lot of changes. When we first started in 2015, to be honest, we don't see a lot of news in this part of the world. But today, I think it's very different. I think, the world has kind of awakened, especially over the past 2 years, to the need to really do something urgently for the climate issue that we're facing globally. So as I mentioned, we are right now in the second fund. We are still fundraising. We closed it up, but we've raised 66 million so far. We have to raise 100 million, and of this, 6 million we deployed across 12 companies, and of which Green Lion is one of them. Yeah. So well, that's in a nutshell who we are, and then maybe at this point, I'll just pass the mic back to you, Richard.
Mike, how did Lawrence and Melvin have the idea for the fund? Do you know anything about the origin of the fund?
Oh, good question. Yeah, so Melvin and Lawrence, they both come from investment banking background, but they decided that they have enough of the banking world. They decided to leave the banking world. And what happened is that Lawrence actually started a company called Sunseap, which is a solar utility company. And that was like in 2011. Yeah, so it's way, a decade ago. And if I'm not wrong, it is the first solar utility company based out in Singapore and probably even Asia, ex-China. And Melvin is actually the first angel investor into Sunseap itself. So these two gentlemen have a deep belief that something needs to be done to resolve the climate issue that we're all facing. And they took the plunge. They took the plunge. At that point of time, solar is not what we are seeing today. Solar then is it's not. I mean, you can't get the price parity from the power generated out from solar versus fossil fuel and traditional sources. But they believe that one day that will happen, and they've been proven correct. So that's how they started in the sustainability field, in the climate field. And it's through this involvement in the company Sunseap itself that they started seeing a lot of deal flows coming to them, people looking for funds to invest. They put in their own money initially, but they realized that that's not sustainable. All right, and to get really good deals, you definitely need bigger checks. So bankers being bankers, they go out, reach out to people whom they know, reach out to family offices that they know here, sell the story on climate tech, and that's the genesis of TRIREC. That's how TRIREC was started.
Okay, and how about yourself? There's a big argument in the industry about whether general venture capital funds have a better return or specialized venture capital funds. What was it that really prompted you to move into this kind of climate tech focused fund?
Okay, I mean, a little bit of background. I mean, I've known Lawrence and Melvin for a long time. In fact, we were colleagues at a certain point of time in the investment banking side. So I've seen this guy doing what they do, whether it's in Sunseap and subsequently in TRIREC. In fact, I brought some deals to them as well during my investment banking days. And I've seen how the whole sector has played out. I think when they first started, the whole industry is really in a very nascent stage. In the early 2000s, I think we have got the clean tech 1.0 story, which didn't really pan out. But I think like in a lot of this new investment area, right? It's like we have the .com in early 2000s as well that didn't pan out, but then we have a big tech boom. It's like every decade there's a boom and bust kind of thing. So I personally believe that I think we are at that point of time right now that climate tech, sustainability tech is entering into the decade that is going to see a huge boom at this junction. So that get me really intrigued. And well, I mean, and at the same time, I personally also, I mean, I'm not a tree hugger. I mean, I don't proclaim to be a tree hugger, but I do believe that everyone has a role to play when it comes to solving the climate issue. And I think this is where I should put in the experience and skills that I have to play my part to solve this problem.
Okay. And I see that Green Lion is one of your newest investments. It's over here by 2022. So yep. You all participated in the investment just this year, right?
Yeah, in fact, just a couple of months back.
Okay. So maybe now is a good time to turn the microphone over to Leon and ask Leon to tell us more about Green Lion. Mike, you can stop sharing your slides.
Okay, just give me a minute.
Leon, welcome to our program this morning. Delighted you can join.
Yeah, good evening, Richard. Thank you for having me. Hello, everybody, and thanks for joining in your evening. I think Yeah, I can also share, Richard, if that's okay.
I think that would be great. Tell us a little bit about Green Lion and I may ask you a few personal questions about how you got involved in it too.
No, that's fine. I mean, sorry, I've got a frog in my throat. I do want to say though that it's hard for VCs maybe to and Mike to explain, why they stand out. And I do have to give a little bit of props to Mike and TRIREC. They're very, very unique as an investor for Green Lion, because to say that they truly understand hardware and clean tech is an understatement. And I think that they stand out so much because they're actually founders, which is unique. When you're raising money, you speak to millions of people, millions of very, very elite financial minds. But it actually takes a founder and somebody that understands technology deeply to actually help you beyond just cash. So yeah, so they're one of the good ones, I must say. So
that's a great endorsement. And
thanks
you're absolutely right.
Might also be aligned with the fact that he's helping me with more money. But I mean, that's how a good VC helps, right? They help you on your journey. But yeah, I don't want to bore everybody too much. I think that Green Lion is something I could talk about for hours, but just very briefly, we are a technology solutions business for the lithium-ion battery industry. We're trying to create a circular economy for lithium-ion batteries. Why are we doing that? I'm not sure if you all know, but I'm sure many of you know that only 95% of all lithium-ion batteries are actually recycled. Only 5% are recycled today. 95% go into landfill. Of that 5%, 2/3 of that gets recycled in China, and so the rest of the world, we're really doing a dismal job of recycling or reusing these materials. Currently, if you look at the world's total mining operations, there's not enough operations to keep up with the demand of materials for batteries. So even if we mined it, we put every mine to work on just battery materials, we still wouldn't have enough. So we need to reuse the materials. So, what are we? We build a large piece of kit. We build the machine up in the top right-hand corner. This is a module that can be integrated or installed straight into a current lithium-ion battery recycler or a battery manufacturer to capture either crushed lithium-ion batteries or to take production waste. What it does, and if you strip away everything, our process is greener, faster, more profitable, and creates pure outcomes. And by what do I mean by that? We take in crushed batteries. It's the first process in the world that can take in all 6 types of lithium-ion batteries that are on the market. So that could take, you're in California, so most of you will have a Tesla, I hope, and it could take a Tesla battery, an iPhone battery, your kid's toy, a power tool, any battery that exists in the market, crush it all together, which is unique because prior to that, you had to sort it. It goes into our process and we remanufacture what's called PCAM, or cathode active material, and lithium carbonate, as well as discharging graphite. So it goes straight back into a battery to be reused. Why does that solve a problem? Because at the moment we're not doing that. We're crushing batteries and we're trying to separate the metals. What crushed batteries, we refer to it as black mass. So black mass is worth about $2,000 to $5,000 a metric ton. We put it through our process, or the GLMC1, which this machine is called. And at the end, we produce a material which is worth $39,000 a metric ton. So we're jumping up the profitability of the machine by a good good measurement. What that does is if we strip everything away, if we make battery recycling more profitable, it will happen more often. It's important in the US at the moment as you're trying to create domestic battery materials without mines, of course. If you put in a metric ton of black mass into this machine, if you put 1 metric ton of Chinese batteries into our machine, then the outcome will be American-made cathode material to go straight back into batteries. So this machine that you're seeing on screen is built in Houston, Texas. Not too far. It's 150 metric tons in size. It stands 28 foot high. Trying to go from meters to feet. I think it's about 60 foot long. So you can probably tell it's a fairly large module. It's relative, but we install that on our client site. This machine is low pressure, low temperature. It takes the amount of energy of a small house. So it's 8 times less carbon footprint than anything in the market currently. A lot of battery recycling happens through pyrometallurgy, which is using huge furnaces, which you can imagine the carbon output and the impact on the environment. It's faster because there's no sorting, but we actually cut out 2 supply chain players. So rather than what happens currently in the US is you take a spent battery, you crush and shred it, and you send it to East Asia. It travels 50,000 miles to be turned. First, it goes to Japan or Korea, typically to be refined down to nickel, cobalt, manganese, and lithium. And then those elements get sent to another player, a cathode manufacturer or battery manufacturer, to be rebalanced and created back into cathode material or PCAM, which is what our machine does every 10 hours. It processes 1 metric ton. So, and as I said, it 4 to 10x's the profitability, which is the real problem that we're solving. This is the current supply chain, which we just touched on. I don't want to bore you too much, but I do want to talk really, really quickly about our business model, because if we're talking about circularity, really it's a battle against consumerism, and we need to, if there are entrepreneurs or startup people in the audience, I mean, the best thing I believe that we can do for circularity is create a model where there's no ownership, where we can lease and license different pieces of technology, and that's what we do. We take $3 million upfront for the machine, and then we deploy it and share in the profit with the client. So it's a tolling fee or a production sharing agreement. I may have stolen it from my previous industry and when we built large assets for offshore oil and gas. And really, if we can regenerate and rebuild, remanufacture battery materials and track that battery all the way back to Green Lion's process and then remanufacture it again, batteries have such a unique property. Unlike other energy sources, it can be reused in an infinite amount of time, and we can remanufacture it to as high a grade as the raw material, and we can do it thousands of times. So really, that's what we're trying to do. And if we can have all the startups trying to create circular economies in their own domains, I think that's how we stop taxing the environment so much. And I'll kind of finish there, but before I sort of close out our technology, I'd rather answer questions, to be fair, than harp on or monologue. But I can't really speak about our technology. It'd be like talking about the Sistine Chapel and never mentioning Michelangelo if I don't mention Dr. Katal. Reza is, other than being one of my closest friends, he's a very, very inspiring man. He worked 10 years on the IP that we've generated and the 6 patents that we have. I affectionately refer to him as a typical Iranian. He only has 6 degrees, but he is unique because he's worked in the industry and he's really had hands-on experience recycling lithium-ion batteries for 10 years, which makes him a bit of a veteran or a pioneer, because it is a little bit nascent, the industry, but we hope it grows. So yeah, thank you very much.
Okay.
That's all.
Well, that's a good stopping point for now.
I hope to sort of engage more in questions.
Great. Leon, how did you meet Reza? How did you two meet each other?
Yeah, that's kind of a fun story. The Singapore government has a sort of department called SG Innovate, and they really they host events and they try and put together the graduating PhDs and the greatest sort of minds coming out of their university here in Singapore. And they try and match them up with disgruntled corporate people. So I was invited to some of these events, and I met Reza, which obviously changed my life for the better. And it was very good timing because it was as I was exiting my previous company. So
okay. So I'm curious, you started off by mentioning that, you know, only 5% of lithium batteries are recycled ever. Why is the percentage so low? What's really hard?
There are many elements that makes it difficult from a technology and even chemistry perspective. But the reason is, I think, simplistically, that the batteries are not being collected. Governments and whatnot, other than China, didn't make it important and didn't see the value in the material. It's only, like all commodities, it's only been when demand goes up and supply doesn't grow in line with that everybody started focusing on it. But I guess even more so than any of that is back to my first point. There wasn't a way to make money in battery recycling, only at volume. And the Chinese did it very well at volume and still do. But they had a lot of government support to get there. And you know, the science to make it profitable and bring down OpEx and improve the value and the purity of the outcome is difficult.
Okay, so we've got some great questions that have already come in on chat, but I'm kind of rearranging them for the people who've asked the questions. I'll be sort of asking them out of order. I'll probably get to your questions though. I'm curious, lithium-ion batteries have a bad habit of exploding. And so if you're crushing batteries in a giant machine like that, how do you keep them from catching on fire?
Yeah, it's a good question, Richard. So we install our machine on a client site. We retain the title and the ownership of the machine, and we effectively we co-operate the machine. So our client needs to have a safe and efficient way of crushing and shredding batteries already. Part of our due diligence on our client will be that they do that effectively. We've helped them with some of the engineering, some of the newer setups, and if most often in industry we use a nitrogen blanket to be able to crush the batteries safely, so there's no explosions.
Okay, so does that mean that you would actually, the feedstock that you're actually using to recycle is something that your partner would be responsible for getting?
Yes, absolutely. That's 100%. So we take in that product called black mass is our input.
Yeah.
Crushed black batteries or production waste. So one of our clients is one of America's largest battery manufacturers, and they give us a slightly different product. They feed in production waste. So that's much purer, but we remanufacture it for them back into material that can go into their production line.
So the the facility that was in your video is doing about 2 metric tons a day, you said? Did I miss that?
No, you're absolutely correct. So
Is there an upper limit on scale or a sweet spot for the size of the plant? Are you happy with the size? Do you want to make it even bigger?
we quite like the size at the moment because we charge an amount per machine and we sell it as a module. So, for example, our first client put an option on 20 machines, which they'll buy many machines and have them lined up. There is a restriction, and that is how big is your facility and how much roof space do you have. Right now, you need a minimum of 30 foot for this machine. If we go bigger, you need more space. So that's what limits it. The reactions can be scaled up, and these tanks can be scaled up. But there's also an argument to having modular, smaller modules, because we produce any type of NMC or LFP cathode material. So what that means is we produce 1 series, 5 series, 6 series, 8 series, 9 series, all of these chemistries for different batteries. So there is an argument that you could have many lines, production lines, produce many different types of battery material.
Yeah, that was actually kind of a question that I had, is are different types of lithium ion batteries really drastically different, need to be treated separately?
Well, not in our machine. They can all come in together. To give you an idea of scale, 2 metric tons is about 70,000 iPhones, 56 to 70,000 phones, depends on which ones, and or 10 to 20 large scale EVs being crushed in there per day.
Okay. And so I noticed that your slide said that the partner with you in this sharing model, they recoup their investment within 6 months.
Yes, well, it can be even quicker if they use it at capacity from day one, which isn't very realistic. There's a scale up period and commissioning, of course, but the return on investment, the business model is that we are a startup and we don't have much cash, which is so we keep the upfront payment very, very close to the cost of build. We make a little bit of money, but it's not impressing anyone. Where we make the real money is where we share on the production profit, and that's very, very conscious. We want the agreement and the way we engage with our client to motivate both parties for the best possible outcome. They understand that we're in it with them, and we don't make money unless they make money.
This is a great way to do business. Do you have to customize each one of your sort of machines for the specifics of where it's going to be? Or is it pretty much a standard machine that you can easily send to somebody or install for somebody?
We wish that it would have been a standard for everybody. We do have to tweak and especially the inputs and the machine for voltage. We've got machines going into the Americas and Europe and Australia and Asia. So there are tweaks everywhere in the world and for every client. But we have two different products. I guess the one that you saw is called the GLMC, which is very unoriginally green line multi-cathode. Means you can put in any type of battery, and out we can make any type of NMC material. But maybe to answer one of the questions in the chat as well, our other product is the GLLFP module, which sometimes we sell with our larger machine. The GLLFP machine is the first technology in the world that can handle LFP batteries and remanufacture the LFP cathode material. So why that's a problem? LFP batteries cannot be processed in pyro. Well, you lose, fire or heat, and lithium, as you mentioned before, don't play well together. So pyro is not an effective method. And through traditional hydrometallurgical processes, you can't handle the phosphate. Phosphate is troublesome. So maybe to answer another question is that Green Li-ion uses an advanced format of hydrometallurgy, electrowinning, and we've combined a few different sciences in our technology. So in the GLLFP, we're able to manage not only the lithium and extract it at a very, very high yield, we can also handle the phosphate, and then we can bring it back and co-precipitate or use our trademarked green hydrorejuvenation process to rebuild the LFP battery material. Yeah.
So I know that we've got a number of questions about the batteries and about what Green Li-ion's doing, but I don't want to let Mike off the hook too much. Mike, I'm curious, when you first saw Green Li-ion, had they already been in operation somewhere, or were they still in development?
Good question. When we first met with Leon, at that point of time, they really have got a pilot that's up and running. So in terms of technology readiness, it's basically ready for scaling up. But it's at pilot stage, right? So that's typically where we like to invest as well, right? The technology is ready, has not really gone up to the market yet, but it's definitely not at the concept stage.
So if I can ask, what was it that was distinctive about Green Li-ion that made you really think this company as opposed to another company involved in battery recycling?
Yeah, I mean, so obviously we have been tracking the space. We have been tracking the various players that is in the space. And what really stood out for us for Green Li-ion is, I mean, I think Leon did a great job just now explaining the technology that they have and then answering some of the questions. I mean, those are great questions, by the way. Those are questions that we VC ask as well, right? How to differentiate yourself from what is existing in the market? What happened if the new technology coming on stream, and how do you actually position yourself to avoid your technology being obsolete? And then from a customer perspective, is it profitable for them, and what's the ROI like? So I think from the technology point of view, they have actually come up with something really interesting that is very unique in the market that we have not really seen. Obviously, there are new technology that's coming up, but I think many of these are actually still in the very early stage, very early days, and it will take some time for them to actually scale up to be commercially viable. So technology definitely stand out, in our opinion. And the second part, obviously, is we are quite, I would say, very important for us is actually the founders itself. Right? So when we speak with them, we speak with Leon, we speak with Riza. Leon is a great commercial guy with a lot of experience, while Riza is obviously a tech genius, 6th degree. Yeah, so I think these are the two things that really stood out for us when we look at Leon.
Okay. Leon, kind of back to you for a minute. We're getting all kinds of great questions in chat. For people in the audience, let's get ready. I'll ask you to raise your hand, and Kimberly will give you a microphone when you have a question that you would like to ask. Yeah, let's go ahead. Go ahead.
Thanks for taking the time to speak with us. I have a question for both of you. So it sounds like the business that we're talking about here is like very capital intensive, hardware heavy, obviously with really big potential returns. I'm curious what opportunities in your daily work you've seen in software and maybe around supply chain and analytics. Thanks.
Why don't we go with Leon first, specifically to your business, and then more broadly, Mike, what are the kind of software things that TRIREC is interested in? Leon?
I think Mike will answer this question much better. I think what I know about software, you could write on the back of a stamp. But yeah, I mean, there's in our system, of course, it's completely automated and IoT controlled. So in our business, it's all about optimization, getting the data as quickly as possible, and helping it to feed back into the production loop and the control system to make changes and efficiencies. So there's specifically to our business, it's those sort of optimizations which we look to do. The greater business, somehow managing supply chains. The biggest problem is is still collection of batteries. So how do you systemize that? How do you tag? How do you track batteries? How do you keep the OEMs responsible? Europe, Singapore, Australia all have the end of life producers responsibility legislation, whereby the manufacturer needs to recycle their batteries. But how do you actually track it and keep them responsible? Maybe there's a play there.
I kind of have a technical follow-up that has to do with the composition of the output of your process.
Mm-hmm.
Because, and I'm picking up from one of the questions in chat that, black mass is not standardized, and from different sources, you have different levels of impurities and so forth. Are you able to predict exactly what the output's going to be like, or do you have to test each batch?
Yeah.
And also, is it hard to sell?
So it's a very, very good point, and it was approximately 3 years of pain to us. We had the process quite locked down in the lab. We had the core process completely complete, and we wanted to go to market, or Reza wanted to go to market. The answer is you can never predict what's in black mass. It's always going to be different. Every batch will be different. And that's the core. If you really break down our technology, that's one of the 3 completely novel parts of our science. So we have to optimize for all impurities. What that means is in the second vessel that you saw, or tank, we have to take a stepped approach or a sequential reaction. We have to create sequential reactions, first attacking aluminium, then iron, then phosphate, then titanium, then copper. Organic materials, and before that, fluoride, which is so complex, and it has to be automated. So what happens, not to bore you all, but we take real-time data from a machine called an ICP that tests the solution for that material, and we discharge it when the reaction has separated that material, and we don't go on to the next process until it's 100% removed. There's a constant real-time loop creating those reactions, managing pH, speed, temperature. So that we can take any type of black mass.
Okay.
It was very complex, and one of the biggest feats, I think, that Reza achieved, actually.
Okay, thank you. Before we get back into the batteries even more, Mike, what kind of opportunities do you see in regard to either circular economy or climate tech, especially in the software side?
Okay, to answer this,
not necessarily related to Green Lion,
no,
but
sure,
you've
yeah.
got 18 portfolio companies, and you're always looking at opportunities.
Yeah.
Do you see particular opportunity areas related to software in this whole kind of climate tech space?
Yeah. So to put things in context, right? Actually, there's a huge discussion right now, right? Whether the focus should be still on the software side or hardware side. And if you look at how the investment world has actually been evolving, the past 10 years has actually been a lot of focus on the software side. I mean, if you go to Silicon Valley, basically that's the focus for the past 10 years. But we started noticing that things actually have started shifting. There are more and more people out there that are starting to look into the hardware space as well. Why? I think one of the reasons is if you look at the problem that we're facing in the climate area, you need the hardware to come in, right? It's inevitable, right? I mean, you're talking about things like batteries, you're talking about things like energy sources. You need the hardware to be there. I think to answer that, I think it's not about software or hardware. I think it's about the integration of both hardware and software that is needed. I think when Leon explained the process just now, he kind of alluded to that. What we saw on the slide just now is the machine itself, but to actually run the machine in a very optimal way, you need both hardware and software to come in. I mean, you need to have the data loops to go back so that you can actually analyze the solution, live, and then you can do adjustment accordingly to make sure that you get the outcome that you want to have. So in our opinion, from TRIREC opinion, it has to be a combination of both hardware and software.
I think that's a great answer. I think that's really important, and they actually have to talk to each other too. Leon, or Mike, we've got another question from the audience.
Hey, Leon. Hi, Mike. I also have a question for both of you. I myself ask myself, I don't have a technical background, if it still makes sense to work in a business role and build a startup. I saw, Leon, you also don't have a technical background. And I was wondering what kind of challenges or problems you faced with that. And to Mike, how do you evaluate startups or business founders that don't have a technical background? Yeah.
Those are great questions. Leon, why don't you go first?
Yeah, I think it's important that if you're building technology, if you're building something, especially deep tech, you certainly need domain experience. So my advice would be absolutely jump in wherever you're passionate and you're willing to, put up with the late nights and no cash, but do so with a partner, a co-founder that does have the domain experience, the technical experience. Mike can speak more about what VCs think about people with no technical background, but I guess why Reza and I, my previous background is building large assets for the oil and gas industry and the offshore wind industry. So from an engineering, I'm not an engineer, but we, at least together, we had enough conceptual and practical experience building things. But I relied, heavily on Reza with all things technical. And he was very, very trusting and very kind day one to rely on me and trust me fully with all things commercial. So I think if you find that relationship, you're absolutely fine.
That's also a great answer in terms of, it's the team. Mike, what do you look at when you see teams with people who don't have technical background?
Yeah, okay. So in fact, we often have the opposite question that we need to answer, whereby we actually see a lot of deep tech guys, mainly from the Institute of Higher Learning. Fantastic technology that they have, but most of them are either academia or very research focused. So when it comes to commercialization, actually they don't have that know-how, and that's where I think there's a lot of opportunity out there. That if you have the commercial know-how, you are experienced in GTM, go-to-market portion, you're understanding, you have strong experience in building team. Actually, yeah, I mean, it's great opportunity out there. But like Leon said, go look for a co-founder that has got very deep tech domain knowledge, very good technology. Yeah, and they're looking for somebody who have the same belief, same principle, same values to come together to do a startup. So yeah, okay. I think that's the way to go, if you have to ask me.
Okay, thank you. A couple of questions out of chat. Mike asks if the refining process results in toxic wastes that cannot be used or sold, And if so, what do you do or your clients do with those materials? Leon,
Yeah,
that's for you.
That's a good question, Mike. So the process, we discharge a few different elements. We discharge graphite, which is sold and used in batteries, of course. The second, though, is the mixed non-precious metals, which I mentioned. That is sold to the cement or building industry. Actually, they do use that material back in cement. It's not worth much, but it is picked up and reused. The second, of course, is the PCAM material, which is very valuable, and then the last one is lithium carbonate, which is very valuable. So what are our byproducts? Our byproducts of water. So we reuse 90% of all the water that comes out of tank 4. We put back into the tank 1 and reuse it back in our system. And the other byproduct is sodium sulfate. So sodium sulfate we sell, and then we have water which we then extract from our final product, which where our client will take that 10% of water when they pick up the final product, and they'll have to handle that, because that may have trace metals in it, which they usually have a water refining process. So there's no toxic discharge out of our system. And it was very, very key to the conscious in the design of the machine not to have toxic discharge. So that's where you run into a lot of problems with the environmental protection agencies in different locations. Yeah.
Yeah, so some time back we had a question about the role of recycling in the whole battery supply chain, and I think this probably goes to Mike. Do you see kind of 50% of all battery materials being from recycled sources, or how do you see this developing? Do you think this will really be the mainstream for the battery industry in the future?
Well, in fact, I think this question is one of the main pieces why we think bringing on is a great investment. In fact, we don't have to wait till the materials being used for batteries are 50%. In fact, if you look at the current supply chain situation, the way that the requirement, the demand for minerals and precious matter and rare earth matters is going to go off the roof. And the issue that we're going to face pretty soon is that there will be a huge gap between demand and supply. Right. So in terms of the demand supply issue, I think it's inevitable that recycling has to take place. I think that's one. And the second part that if you look at it is actually look at the geopolitical situation right now, especially over the past 2 years. Everyone is getting very, how should I say, they're getting very protective, especially of very rare commodities. Right, so everyone's now thinking, right, how can I secure the minerals and the metals, etc., especially if they're coming from elsewhere, and especially if they're coming from somewhere whereby not very friendly to us, right? So I think one of the best way to actually do that is to actually optimize what you already have, and therefore recycling is definitely one of the routes for you to actually secure some of these very precious stuff, very precious commodities that you need going forward.
Okay, thank you. Quick follow-up for Leon. Is there a kind of battery, an energy dividend to making a new lithium-ion battery from recycled material versus making it the other way? Do you save the next generation of manufacturers a lot of energy or a lot of cost by providing the material you provide?
Well, there's a financial and but also environmental dividend, I guess, from reusing recycled material, because it performs at the same level as raw material and it costs up to 5 times less. There's that obvious financial saving, which I would like to think is passed on to the consumer, but probably not. The other way to look at it, though, from an environmental impact perspective, is the carbon footprint of our process, for example, or any recycling process, is minute compared to mining this out of the ground. You know, we're conducting a cradle to grave LCA, life cycle analysis, now on our process in comparison to competitors, but also mining. We see that 55% of our carbon emitted or footprint in our process comes from transport. So if you can electrify the transport of our process, we certainly become eligible for credits and whatnot. Or if you simply put our machine right where the batteries are being used and they don't need to move around, and then you also remanufacture and you close the loop in location, it's certainly it certainly reduces our impact.
It's really good that you're thinking about all aspects, including the location of where the facility is. We've got a question from the audience. Go ahead.
Mike, and hi, Leon. Thank you so much for coming and zooming in. My question, I believe, Leon, you might have been alluding to the IRA. You said 1 metric ton of Chinese batteries will become American-made cathode material. So I just wanted to ask explicitly, were you referring to that, and what opportunities are there? And if not, what other legislation around the world, like the European Extended Producer Responsibility legislation, can you speak more generally, like how this global supply chain might play out and where the regional focuses might be in the coming future? Thank you.
No, that's a great question. I mean, absolutely, the US is, even yesterday, the US is doing great things for the industry to try and support reuse, domestic manufacturing and creation of battery materials. So I guess the two hotspots for us are, of course, US and Europe, seeing as we've taken a strategy not to move into China until we're a little bigger and more robust. So US and the Inflation Reduction Act has made it such that machines or technology like ours that can remanufacture batteries from anywhere in the world and produce a material to go back into batteries that's effectively classified as domestically produced is very advantageous, and we certainly can. Our clients can take advantage of some of the subsidies, tax breaks, and even grant funding on the ground there. And why I say our clients is because they're operating the recycling and the full cycle process. I guess we're just licensing and selling the machines to them, the technology. And then if you look at the EPR legislation in Europe, that's forcing battery manufacturers to use recycled material, so which is fantastic, and that's a needed move, and we're hoping that other sort of jurisdictions follow suit. So what that means is that manufacturers need to start to test our material, use our material, build cells out of it, which is of course, again, useful.
So kind of from the chat, we actually had a question about that. To confirm, the materials you produced would be considered made in the location where they're actually doing the recycling. So if the machine is in the United States, it's considered domestic United States material.
Yes, and it helps that our machine is actually US made as well. So you're correct, Richard.
Okay. And kind of as a follow-up question, this is from chat. In general, have you run into any policy bottlenecks in your work, or what are the big kind of concerns for, government regulators that you would have?
Yeah, I mean, Fred, I can see Fred's questions that he must be from the industry or understand it well. They're very good questions. The policy bottleneck, I guess, is that around the ability to set up recycling facilities. Recycling facilities still have different states have different regulations and permitting requirements, but it's quite hard to set up a battery recycling facility. For example, you need to keep your batteries on a different location to where you do your crushing and shredding. And it seems a bit strange because eventually you need to bring your batteries where you're crushing and shredding them, of course. But there's a lot to prove, and there's a lot of capital investment for these guys before they can get approval. And they may or may not get it quickly or maybe ever. I think they always get it eventually, but your money, your investment is sitting there not making any returns until you have a permit, of course. So there is certainly some bottlenecks in the US, and different countries have different problems. But we personally have infrastructure bottlenecks, which we are actually addressing now with our VCs, and specifically Mike and TRIREC, to around the long lead items to build our machines. Supply chain globally has been impacted by COVID and geopolitical issues. So I think, Fred, you might be, asking that. And we're pre-buying. We're pre-buying everything long lead is the answer.
Conversely, Mike, I'd like to ask if TRIREC is looking at government financials incentives as a major factor in wanting to invest in green companies, or is that sort of just nice if you have them, but not something you really pay much attention to?
Okay, I think for this whole landscape in terms of climate change, the government regulatory environment do play a very, very large role. I think we have to be quite clear on that, right? Because a lot of things, like Leon mentioned, there is no impetus for the industry to make the change unless the government put in policies that actually encourage them to make the change itself. But having said that, when we do look into the startup itself, we understand the need for this regulatory push, but at the same time, we are very aware that it shouldn't be the key whereby the company will be successful, right? Especially from a financing point of view. Yeah, I mean, just to add on to what Leon mentioned, and one of the questions earlier, I think just 2 days ago, if you're not wrong, the US just announced $28 billion worth of grant specifically for the recycling of battery in the US itself. Whether you are in the recycling field or the technology that can do that, I think the government in the US is, strongly encouraging the industry to be developed. I think going in the next few years.
Okay, thank you. We have a question from the audience.
Thank you, Leon and Mike. I have a more general question, but a very important question in terms of development. And basically, what is your strategy for protecting your IP and proprietary elements?
Yeah, that's a very, very important question. Is it okay if I answer, Mike?
Yeah, go ahead, man.
For us, Mike can answer probably, in general terms, and across more exciting businesses. But with us, we have to do it. We have to take a few approaches, and it's never perfect. One is spend an exorbitant amount of money with the best lawyer that you can find in IP that specifically understands your technology, if possible. So we of course have six patents, and we have trademarks, and we have so that is trying to protect it legally, and also take those patents global, register in all the countries that you can, and specifically that you're worried about. Secondly is contractually. So part of the reason that the model is such that we own the title to the machine, and that it's a licensing agreement, is so that we can kind of keep tabs on our machine. We can make sure that if it's reverse engineer, anyone tampers with it, we shut it down remotely, we decommission it remotely. We also provide a full-time engineer to cooperate the machine. So he's our bodyguard. So we try and do it physically, contractually, legally, building a long-term relationship with these clients where they profit a lot. Hopefully the motivations also line up with ours. But none of that's perfect. You know, if someone's really, really motivated to steal from you, they would have to reverse engineer our machine and understand it mechanically. And from an engineering standpoint, then they'd have to steal our code, which we don't share, obviously. And lastly, they would have to understand the chemistry and the reactions, which we also don't share. So we try our best, but I guess the only thing we can be is very, very paranoid and make sure that we keep acting that way until we're big enough. And we get good partners like TRIREC and other investors, which give us enough cash to scale quickly, so that hopefully by the time someone catches us or steals from us, we're big enough to survive and or fight.
Great. Mike, follow up for you. How do you look at intellectual property when you're evaluating a potential company and deal flow?
Okay, yeah, I mean, twofold basically. I think the first part is obviously, is the technology that the startups are working on. Is it really novel? Is it really unique? And how defensible it is, and how commercially viable it is. I think that's the first part. The second part, I think, related to the question is, then how do you protect the IP? I think, like Leon has alluded to, as much as we want things to be patented and trademarked most of the time, there are certain things that you can't, right? This is just way too expensive to protect everything. That's number one. And number two, in many cases, actually, sometimes you do not even want to have it out in the market, right? Because if somebody wants to breach that and they're in a jurisdiction that you have no way of getting them, you just rather keep it, as a black box, right? So there's no perfect solution to it. And again, like Leon mentioned, I think you have to build layers, all right? You have the hardware layers, you have the software layers, you have the chemistry layers. You just have to build that stack eventually, yes, there's a possibility of doing a reverse engineering, but just want to make it difficult, right? It's like you want to do it, yeah, sure, but you're gonna take a lot of time, you're gonna take money, so you just make it not worthwhile for someone to actually try to do that. I think the last bit is probably not really related to the IP, but I think you have to see it from a holistic point of view, is that the business model, right, has to be defensible in the first place. So in Leon's case, that's the reason why we think it's important that we have enough firepower. We go out there and we put our foot into as many customer base as possible, because a lot of this kind of technology is entrenched the moment you're in. Because CAPEX has been spent, it has been optimized, so it will be very difficult, right, for somebody else to come in to try to change that or try to replace you. So it has to be a multifaceted way of defending.
Okay, thank you. Another question from chat, and this is really, Leon, in terms of the window for your company, for Green Li-ion, in some ways is related to the window for lithium-ion batteries. Do you see replacement technologies like iron phosphate impacting your business anytime soon? What kind of strategy do you have in that regard?
Yeah, I mean, that's a good question. And that's why we really built that second technology, the GLLFP, that handles iron phosphate batteries. So we're very much in good stead for the market change if it does move to iron phosphate. That being said, battery recycling, we don't we need to be aware of the upcoming technologies, but remembering that when a technology hits the market in volume, we've got 10 years, typically to sort out a solution before it comes in volumes of spent batteries. So we've optimized the large volume of high performance batteries, of course, and EVs is all NMC. Our technology can take LCO, NMC, NCA, LCA, LFP, iron phosphate, of course, LFP, and all of these current batteries, and we can handle solid state batteries, sodium anode,
Wow.
all silicon anode, all of these things we've already tested through our over the last few years. We've been running our prototype, of course, here in Singapore. So we're okay with what's known in the market now. Will there be something crazy that comes out? Maybe. And will it trip us? Will we be able to handle it? Maybe not. But what we know that in the last 20 years, the chemistry of batteries hasn't really changed. So we're fairly confident that that beyond the next 10 years is when we would see the volumes come to us. That probably is not going to change too much away from what we know is in batteries today. There'll definitely be different mixes, different chemistries. But yeah, we feel pretty confident about the future. We're always innovating. Our value and mission is to innovate ahead of demand. We always have to be ahead of demand, and that's why we're working on products that even recycle different products like solar panels and whatnot.
Okay, thank you. That's a very great answer. We have a question from the audience.
Mike, I have another question for you. I worked over the summer for a climate tech investor, and we also looked at the black mass recycling startup, and we didn't really have the expertise in the team, so we didn't end up investing. But I was wondering, how do you, apart from the IP, evaluate the technological risks? I have to add that it was also a pre-seed investment, so the technology was still at lab scale. Probably for Leon, this was different. But I was wondering, if you don't have the expertise in the team, do you talk to experts, or because there's probably like 20, 30 labs worldwide, and we had a really hard time like choosing the right horse, or who has the best technology. How did you do it in that case?
Yeah, it's always a challenge, right? There's so many technology out there, and spread out all the days. And yeah, it's always tough to evaluate a very new novel technology. So what we do is basically, we do our own in-house research, definitely. But at the same time, we do have a ecosystem of partners that's all over the world, especially in the research facilities, in the IHL, Institute of Higher Learning, whether it's in the US, in Europe, or in Asia. And that's where we actually reach out to them to get their perspective. There are cases whereby we do engage some of these guys to actually help us with the technical due diligence of the technology itself. But just want to point out is that when we do the technical due diligence, we basically don't just look at the viability of the technology, because sometimes it's so novel, it's very hard, right? It's basically it's the call that we are making, right? Whether eventually this will be the industry that the technology that will be adopted. But what we really want to know is this really something unique? Is this something really new, right? And from a science point of view, is it even possible, right? So I think that's where the DD expert comes in. But eventually we will still be the one that have to make the call, right? And that's where we also would need to talk to people in the industry itself. Right. So what we do is basically in-house, we engage experts, we talk to the industry, and then what we do is we try to do a triangulation. Is that perfect? Probably not, but I think that's probably the only and the best route that we can have at this junction to pick the right horse.
Okay, thank you. Fred has asked a couple of specific process questions, but I'm going to turn them around to kind of keep them real general interest, if that's all right. I'm curious, are there things that you can't get from old batteries? And also, are there things in your process that you see as sort of next steps that you really want to improve? Leon?
There's not anything that we can't get from the batteries. I guess one thing is that you may have noticed that I mentioned that we extract copper, and then that copper goes into what we call a impurity stream, or a non-precious metal stream. So it's mixed with iron, phosphate, titanium. So, if you've got the capex and you want that material, we can obviously design. What we could do in the future is make sure that we have another process for getting that copper or anything else that becomes valuable in the future. So that's where what we're doing. We're optimizing the machine all the time. We've just managed to bring down the capex by 20% and the opex by 13%. So that's really where we're trying to work.
So your ways of bringing down the capex and the opex, is that a matter of scaling up to larger quantities, or changes in your process?
A bit of both, actually, Richard. So it's a matter of scaling up and changing and finding reactions or solvents or elements that work better. It's also so it's a bit of all of that, but it's also due to the fact that we've now had a sufficient amount of time to coupon test and test materials. Change the machine. The first machine was completely over-engineered for safety. Number one value of Green Lion is we build things that are safe for people and the environment. So that means that we went overboard. It was like a rocket ship. The oil and gas industry thought that this thing blows away even the oil and gas industry for what materials we used, makes it expensive. So when we've had sufficient time to test the safety of different materials, we can bring down the cost. And so that's what we're starting to be able to do.
Okay. And I want to ask a question from Crystal before we go back to the audience, because she's asked about particular states, and I think that could also mean countries in the context of Asia, right, that are particularly friendly to working with in this kind of battery recycling or, purification of the materials. How do you see your international scale right now? You do have operations going on here in the United States. Is that particular state by state and also elsewhere, especially in Asia?
Well, I saw Crystal's comment and I wanted to sort of throw it out to the crowd. And if anyone knows which state in America is we're trying to understand that at the moment for ourselves. So any help would be appreciated. But what we do know is Texas, Louisiana, Atlanta, they seem to be a little bit more supportive of these kind of chemical type processes, because a lot has happened. Traditionally they had those industries. That's I'm sure there's more, but US is such a big, complex place. It's very hard for a company to understand the landscape and where we can get the best economic efficiencies and speed and support. From a global perspective, fortunately or unfortunately, China's probably one of the easier places to do battery recycling. It's unfortunate for us because it's one of the chosen no-go zones for our company. Europe, there's you see a lot of battery manufacturers and facilities going into Hungary and Slovakia, Croatia.
I'm kind of curious if I can jump into your answer. Is this because that's where a lot of old batteries are being put into landfill? More than the kind of state financial incentives or regulatory? Does it really have to do with where old batteries are?
No, not so much. I mean, you see some of the biggest users of well, the biggest users of batteries are where the population's the biggest nowadays. The developed world uses far more batteries than of course the developing world. Now, I think some of these countries and states they probably see the opportunity, and so they loosen or maybe put in permitting and regulations that move faster because they can see if they attract these industries, they might be on a winning team. I think I'm not too sure, Richard, to be honest.
Okay, I have another question from the audience.
Oops, I had a question around the electrochemical platforms. So, and also around the long-term vision of the company. So there's some naysayers around electrochemical platforms, maybe the Faradaic efficiencies, catalysts, membranes. Are you running into those challenges, and what would you tell these naysayers? And then secondly is kind of, are there ways to retool the tech that you have for broader applications, maybe for like hydrogen electrolyzer catalysts or anything else in this economy that's electrifying? Thank you.
Yeah, I guess that's a gap in our technology. We don't we don't extract or recycle the electrolyte. That should have been done already. It always is, or it should be done in the production of black mass or recycling. The electrochemical process and the naysayers, I guess there's in all formats of science, there's much that doesn't work. And you know, it's up to the inventors and the scientists to find a way to make it work. Our particular technology kind of works. There's always naysayers saying that this shouldn't work, but it's about, you know, finding a partner like our investment partners, our clients that believe you and trust you. And when you have commercial grade outcomes, or even, I guess, when you've proved it a pilot or prototype, then the naysayers need to eat humble pie, I guess. Yeah, but certainly, so we can adapt to the second part of, I hope I answered your question. And to the second part, we're absolutely trying to adapt the technology to different applications already. So we know that we can recycle or extract a lot of precious material out of solar panels. We know the solar panels is a big is going to be a big problem. Spent solar panels or is coming into the market heavily in the future, and we think we can you know, reduce impact on the environment if we can help there at all. So that's what we're working on at the moment.
That's great. I'm going to kind of end our session by asking Mike for a real general venture capital question. And it's specific to how do you keep up with all of the things happening in Southeast Asia, South Asia, the regions you're looking at, because it's such a diverse place with many different news sources and so forth. How do you keep up with that? And also, how do you see the region developing with these kind of new environmentally driven technologies?
Yeah, I mean, that's one of the biggest challenge, to be honest, from a VC perspective, especially for a VC like us, which is which have a global mandate. You're right. I mean, Asia alone is already such diverse and fragmented, and many things going on at the same time. And how we actually try to, I wouldn't say solve it, but I think we try to mitigate that is basically, we start from the very top-down perspective. As I mentioned earlier, we have 5 verticals, and from the 5 verticals, we dive into the verticals and look at the supply chain itself. And we try to zoom in as much as possible to identify that specific part of the value chain that we think we really want to invest in. And that's where then we will then go up and really scout through the various markets to really understand what's going on for that specific portion of the value chain, and try to talk to as many people as possible, whether it's in the industry, whether it's in the research side, and we work very closely with fellow VCs as well, right? Because these are the guys that are also looking at the same space. So there's a lot of cross exchange of ideas. In fact, I think in the VC world, we don't really see one another as competitors. We see each other as actually partners most of the time. So we have a lot of sharing of views and stuff like that. So that's how we actually try to optimize the process. But I mean, obviously there are times that things will slip through us because just too many things are going on at the moment.
Okay, thank you. I want to close with kind of a personal comment. I have been worried for years about what was going to happen to all of the old lithium-ion batteries that are being produced. That, you know, these things are not great for the environment, and it's a real concern what will happen to the world as they just keep piling up. Today is the first time, and when I first, you know, encountered Green Li-ion, I was really excited to see that you've got, you know, the ability to get the good materials out of these old batteries and really, you know, bring new life and really have something that's more circular economy in this. I wish you all the very best. It's an exciting company. And Mike, I'm so excited that we were able to bring in TRIREC and talk about your views as a venture capitalist. So thank you both very much for a really, you know, enlightening discussion today. Thanks, everybody.
Thank you, Richard. Pleasure.